Welcome to HP ALM Australia YouTube channel. In this demonstration, we are going to show you how to use HP Service Virtualization and HP Service Test to stub out some of the unavailable components in your application. When your application consists of one or more systems, we typically call it a composite application. A composite application involves multiple systems working together to implement a business process. Typically, when you have to test such an application, you run into problems when some components are not available. For example, they might be used by another project, they might still be in development, or there might be third-party systems that you cannot access when you need to, or you need to pay for a transaction. In order to alleviate wait times and the risk of unavailable services, you can use Service Virtualization to create virtual copies of the transactions that you'll be using. You can then redirect your client to talk to Service Virtualization server instead of the real services. Service Virtualization simulates the responses you would expect to receive from your real services. Therefore, as a user, it looks like you are talking to the real system, even when it's not available. On the other end of the system, you might find that some of your graphical user interfaces are not available, or your mobile applications are not yet ready. Or maybe you publish headless web services to be used by other third-party organizations with their graphical user interface. In this case, the input, normally done through graphical user interface, can be simulated by Service Test. Service Test sends the expected requests to your service and then checks the return response for correctness. Before we jump into Service Virtualization, let's first study the application that we are going to be virtualizing. The application we are using is a health insurance claims application. It consists of three components. The first one is a graphical user interface. This is where you enter the patient's claim and send it off to the service behind the scenes. It will first go to the claim processing service, and claim processing service will then send some data to member account service to understand what plan the patient is on. The member account service will send back all the plan details, and claim processing service will subsequently decide whether the amount claimed is either rejected or accepted. When we go back to HP Service Virtualization Designer, we are presented with some getting started options. For this case, we are going to learn the existing service. The service we are going to learn is going to be the member account service, which is the service that returns the member plans. We click on Learn Existing Service, and we are presented with a dialog that is requesting for a service description. In this case, we have a WSDL that we can provide as a service description, but if you do not have a service description, you can select the alternative option. We will copy the location of the WSDL and paste it into our service description. Once we click on the Start button, the service description is being downloaded, and Service Virtualization studies the input and output format of the service. Now we are presented with virtualization properties. We're given the option to change any of those details. In this demonstration, we will select to change the project name. Once we click on Virtualize, Service Virtualization Designer creates a new project for us. The new project has been created, and we are reminded to reconfigure the client to make sure that it now points to the virtual service rather than the real service. We have already done that. Because we selected the Learn Existing Service option, our project is automatically in the learning status. As you can see, there are 4 states that your service can be in. The first state is the learning one. In the learning state, data is received from your client and is forwarded to the real service. In the meantime, Service Virtualization looks at the requests and response data and records this internally. In the simulate state, Service Virtualization doesn't care whether the real service is up and running, and instead sends the data that has been either pre-recorded or pre-populated against the virtual service. In the stop or standby mode, the data is received from the client and is forwarded to the real service. In this mode, Service Virtualization doesn't do anything but simply forward the data to the real service. As we are in the learning mode, let's see what happens when we send some transactions to member account service. When we send the transaction to the member account service, it is received by claim processing and then forwarded through service virtualization to the member account service. During this interaction, service virtualization looks at the data that is being sent and received between claim processing service and member account service and records it in its own data model. In order to populate our virtual service with a rich data set, we are going to send through a few transactions. We have now taught a virtual service approximately 26 different transactions. At this stage, we can stop the learning and take a look at our data model that was learned. Once we open the data model, we can see a member account service and the operations that belong to this service: get member detail, get member plan, and member search. If we expand learned data, we can see the data that was sent and received for each of the transactions. We can also select some of the columns that we may want to work with. As you can see in the data model, the data is stored in a number of different rules. Those rules take an order of precedence. When we are simulating a service, service virtualization will first look to rule number 1 and check if there is an appropriate response. If no appropriate response has been found in a higher priority rule, service virtualization will default to the last response. In addition to learned data and default response, we can add some additional rules. In this example, we'll suppose that we've introduced some new plans. Therefore, we'll add a data-driven rule and populate it with a spreadsheet of test data that we have created earlier. Service virtualization reads the data in the spreadsheet and populates it into a new rule. Therefore, when service virtualization looks to match the request to responses, it will look at the external data rule first. We have the data in the spreadsheet below. What we want to do now is bind the columns in the spreadsheet to the columns in our request and response pairs. We do it by easily clicking on the bind data text and selecting which column we want to match it with. When we click OK, the data is taken out of the spreadsheet and populated into our rule. We save the data model and click to simulate the virtual service. At this stage, we can close the real member account service as we now have the simulation model to work with. Let's see what happens when we try to enter some claims. I will highlight some areas on the output in the claim processing service. As you can see, the plan is now called the Bodyguard plan, and its approval limit is $100. If we go back to our data model, we can see that the Bodyguard plan is one of the new plans that we have imported from our external data. The old plans had different names. We'll try a few more patients. We can see that patient number 2 has been matched to the comprehensive plan with a $1,500 approval limit. Patient number 3 has been matched to Super Saver plan with a $50 approval limit. This data is reflected in the spreadsheet that we've imported. We have the first member with the Bodyguard plan, the second member with a comprehensive plan, and the third member with a Super Saver plan. Let's return to our designer and study some additional features of HP Service Virtualization. We have already seen the data model. Now we will look at the performance model. Let's put our service into standby and open up the performance model that was learned. When we select to edit the performance model, again we can see our service with its broken down operations. In the performance model, we can change some of the performance parameters. For example, we might want to increase or decrease the CPU power, or change the scalability of the service. We can additionally change the settings for individual operations. For example, we might want to change the throughput limit. Additionally, we can go into an individual operation and change the performance profile using this graph. When we lent the service, we only had one user, but when we are performance testing, we might use 100 or 1,000 users. We can then move the threshold and response time on a graph to create the performance profile that we are after. In this service virtualization project, we only worked with one service. If we were to add additional services, we'll use the Add New Service toolbar icon to bring up the New Service dialog. And from here, we can either enter the service description, or if we don't have a description, we can proceed to select from a list of available protocols. We have seen how you can virtualize the services that are not available at the back end. But what about when the graphical user interface is also not available? This is where we can use the service test component of HP Unified Functional Testing to simulate the actions you would normally perform via the user interface. We will begin by creating a new service test. This service test will communicate with our claim processing service instead of the graphical user interface. We are going to import the description of the claim processing service into our tool. From the toolbox area, we can see all the actions available against the claim processing service. The Enter Claim action that we are dragging now onto our visual design canvas is the action that gets called by graphical user interface that we previously used. Against the Enter Claims action, we have a list of properties. These properties list the input data that is expected by the Enter Claims action. As you can see, the fields are very similar to those that we entered via the graphical user interface. Instead of using the GUI, we will enter them here. When Claim Processing Service receives a request via Enter Claims, it returns member ID. We subsequently use the Get Claim action to check whether the claim amount has been approved or not. At this stage, we will insert a checkpoint to check whether our claim is true or false. When Enter Claims returns customer member ID, we will pass that result to the Get Claim transaction. Now the two calls are linked. So now we have UFT service tests simulating a claim processing interface to access the underneath claim processing service, and the claim processing service is subsequently pointing to a virtual copy of the member account service. We return to service virtualization to ensure that our member accounts is in simulating mode. And we will now select to run an end-to-end test. Let's bring up the claim processing output window and view what has been sent and received. We can see the client that we entered in our Unified Functional Testing Properties sheet represented by our log, and we also received a response. We can now check our Unified Functional Testing Results viewer and take a look at our checkpoint. We can see that the claim has been approved. In this demonstration, we showed you how to use HP Service Virtualization and HP Service Test to perform end-to-end tests on your composite applications. Thank you for watching, and please visit our channel for more videos from our team.